Okay. Let's see. The exponents is what we are going to be looking at. So trust me, honorable member, when I say if you can go through these lessons regarding the exponents, there is nothing that is going to come in an exam that you will not be able to know how to work it out or where to start. So this is going to be the first lesson of exponents where I'm going to take you through some types of expressions that you might need to simplify. I think I'll break it down into multiple lessons. So for today, it will be the simplification. And let's see. Then as we continue, we will therefore be dealing with the expressions again, but with rational exponents. For example, where you are given a base to the exponent of a fraction, or to the exponent of 1 over 2, to the exponent of 2 over 3, something of that nature, so that you will also be exposed to when they come in a form of a fraction. And then we will also look into some more examples involving the fractions, where, for example, you might be having let's say 3 to the x plus 1, maybe plus 2 to whatever, then all over again, maybe something like 7 over something. We will also look into those type of problems. And therefore, we will be done with the exponents, whereby as we continue, we will get into the exponential equations. But otherwise, it's fine to get started with other business of the day. Not that much, definitely. I'm going to take you through just a few examples, I think 2 or 3, and then you should be ready to get started. So the first one, maybe let's start with the numbers only. Yes, let's just deal with the numbers only and say, let's say you have 16 squared, that is multiplying inside the brackets, let's say 3 squared, we close that and we say to the exponent of 4, maybe that we say divided by 2 to the exponent of 7, that is multiplying 2 to the exponent of 5, that is multiplying 81. The reason why I have to make sure that we leave no stone unturned, it's because this topic, you continue with it in all the grades. Even when you get to varsity, you'll still be applying the knowledge that you are learning and now. So let's see. 16, but 16 can be written as, what is it? Is it 2 to the 4? Yes. This big basis as the simplest basis. So this one, there is nothing much that you can do with this one of the 3, but definitely, maybe let me write it differently and say, we know that it will be that 2 multiplying with the 4, where you end up having that 2 times 4. And then here, definitely 2 to the 7, it just remains as it is. But remember, the bases are the same. What you do, you add their exponents. Very, very much important, that part. But most importantly, I think 81 is the same as 3 to the exponent of 4. Let me just verify so that 3 to the exponent of 3 to the exponent of 4. Yes, it is indeed 81. So now let's see. You remember the exponents, they multiply each other. So that means you've got 2 to the exponent. What is 4 times 2? Definitely, that is 8 that you multiply. What is 2 to the that? Definitely, that is 8. And then this is being divided by 2 to the exponent. What is that plus that? I think it's 12. Yes, it has to be 12. And what else? Let's see, you have 3 to the exponent of 4. You remember what I said? I said the smaller exponent visits the bigger one, which means this 8, it has to visit the 12. This 4 has to visit the 8, which means at the top, you have 3 to the exponent of 8 minus 4. And then now, this one of 8, it visits this one of the 12. You end up having definitely 3 to the exponent of 4. What is that minus that? I think is 4. So that means you have 2 to the exponent of 4. Definitely 3 to the exponent of 4, we know it's 81. We just saw it now. I tested it. Then 2 to the that, definitely 6. Then it looks like this is the end of it. So can you see how easily you deal with it? No issues, no challenges there. Okay, then it's fine. Let's look at the second problem. Let's see. So let us say you are given 2 to the exponent of x. You close that. Then for there, that you multiply it by 9 to the exponent of that, being divided by 12 to the exponent of 2x. Okay. Okay. This is what you are having. It's fine, it's fine, it's fine, it's fine. Let's see. What else are you going to be having? Let's see. Let us see. Let us see. Mathematically, what I know is that where we are having the brackets, that's where we are going to start. So that means that multiplying by that, you end up having 2 to the exponent of definitely 4x. Then 9, can we not write 9 as 3 squared? 9 can be written as 3 squared most. And then, 12. Can 12 be written as something to the power of something? Maybe not. Then it becomes a challenge most. But I think 12 can be written as 4 multiplied by 3. Yes, 4 multiplied by 3. So just be careful, honorable member. It is that one where you might need to punch 12 on your calculator. You just say 12, you press equal sign, then you click shift, and somewhere on your button, I'm not sure where, but closer to the negative sign, there is FACT, fact. If you click on it, then you will see it will give you something like 2 squared times 3, something of that nature. Then that's how you know that 12 can be written as 2 to the 2 by 3. The 2 to the 3, for me, it is that 4 there. So let's see. Now, no. I did something and the whole of that is going to disappear. Let's see to what extent it's going to disappear. Does it mean it will? Okay, so that. Okay, it's fine. I still remember what I've written. The first example, it was done luckily. And then with the second example, we had what was it? X, and then, no, let me not rush it. X, and then we had 4 there that we multiplied by that, and then here we had 12 to the exponent of 2x. And what I was doing there was to say we definitely have 2 to the 4x that you multiplied by this one, which can be written as that. And with regards to the 12, I'll say it can be written as that times that to the 2x. Yes. Okay. So now, obviously 2 to the 4x, we can just leave it as it is. That times that, we end up having 3 to the exponent of 2x, and then the whole of that divided by. Remember that law. Remember that law which says if you have a base and a different base to the exponent of something, this thing is the same as that base to the exponent of that. You also multiply this base by the same. So it is that by that, that by that. You have invisible one, invisible one. Same here. You have invisible one, you have invisible. Just be very careful of that because that's where you get it wrong. Which means, the honorable member, instead of us writing that 4, we are still allowed to rewrite it as 2 to the exponent of 2, which means we no longer have invisible 1, but we just have 2 there. Why am I showing you that? It's so that you will understand when I say we therefore have 2 to the exponent of that 2 multiplying that 2x. And then 3, you have that invisible 1 multiplying that to x. So that means even if you wrote this thing as 4, it was still fine. It's just that it was going to be a long try because you will still have to rewrite that 4 as 2 to the 2, and then it multiplies again that to x. So now let's see. Let's simplify. We still have that where we multiply this by that, and this is being divided by, what is this times that? Will that not be 4? Yes, it is 4x. Then you have 3 to the exponent of 2x. But wait, why does it seem like this will cancel with that and that will cancel with that? Because they're exactly the same. And you end up having 0. Even if you did not notice that they cancel, but you're going to have a situation where you have 2 to the exponent of that 4x, where you minus by that 4x. And again, even with the 3, having 2x where you minus that 2x. Guess what? You were going to cancel that, and you end up having 2 to the 0. That multiplies that cancelling, and then you have 3 to the 0, whereby anything to the exponent of 0 is 1. Anything to the exponent 0 of 1, and then 1 times 1 is 1. So you just use your mathematical experience to know how to get to where 1 can get to, but in a shortcut. So let's now do this one where you are having 16 to the exponent of x, where we minus 1. The whole of that we divided by 2 to the 4x. What else do? We just multiply that by 32. Okay. So now what are we having there? Let's see. 16, but wait, 16 can be written as 2 to the 4th. Yes. Then we have x, where we minus that. Then now we have 2 to the exponent of 4x there, that we multiply by 32. 32, can 32 be written as something to the exponent of something? I think so. Can it not be written as 2 to the exponent of 5? Yes. So now it looks like we are definitely getting somewhere. Definitely we are getting somewhere, because at the top we have 2 to the exponent of, be very careful. Very careful. This multiplies that, and it also multiplies that. And then it means you have 4x minus 4. Where that is being, okay, the bases are the same. You know very well that what you do, just add their exponents. Very much important there. So now you can take these things to the top, so that you will say, I'm having 2 to the exponent of 4x minus 4. Look at what I do. You see the sign for this one is positive 4x. You write it with its opposite sign because it has now visited the numerator. This one is positive 5. You rewrite it with its opposite sign. I will show you another way of which they might have taught you in class. So now you have 2 to the exponent of, it looks like that will cancel with that. Yes. And what else? Are we having there? It looks like we'll be having that minusing that. Okay, which is -9. Yes, will that not be -9? I think it will be -9. I think it will be -9. Yes. I was just trying to verify if I've copied everything correctly there. So you remember what I said, we always don't want to have a negative exponent. So that invisible one which is there, it will remain at the top, and then you have 2 to the exponent of 9. And what is that 2 to the exponent of 9? It's 512. Yo, what a big number. So that means you have that to the exponent of 512. 2 to the exponent of 9, 512. Yes. Yes, 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 yes. It therefore means this is the end of it. Almost forgot. So this is what I wanted to say. In class, they might have said you're going to say that minus that, and they say you say minus the whole of that exponent of 4x plus 5. You see, be very, very careful to put it inside the brackets, because sometimes you make a mistake where you don't put it inside the brackets, but you just write it as 2 to the exponent of that 4x minus 4. Then you just say minus 4x and then you plus it by 5. No, the minus has to minus the whole of that, because that exponent, it goes as a unit. So that means you will therefore end up having that where you minus that, then you do that by that, you end up having negative 4x minus 5. So you see, this takes you back to exactly what I had there. But if you do it this way, can you see that you've got a problem with your sign there, where that sign for your problem, it is now positive, whereas it's supposed to be negative. So that's all that you needed to be aware of for this lesson. So let's see, in terms of the problems that I'm going to give, I'm going to train you on the types of problems that are related to the first example that I did, example A. And then the next time you can do the types of problems related to B. And then lastly, you will therefore do more problems related to C. So that means you will just be watching this same lesson as a revision, and then you quickly jump onto another type of problem. So it will be 3 types of problem type A, B, and C. But all those types, you just come back to this same lesson and watch it. So the test itself is going to guide you in terms of how you need to work it out. Okay, so I think I will leave it here. Then on our next lesson, it is where I'm therefore going to take you through expressions with rational exponent. For that reason, honorable member, I will just leave it here and say until